Okay, so I guess that we can start, and everyone who join us later are welcome to join us. So once again, hello everyone, and welcome to Joberty webinar. We are very happy to have you hear us today. My name is Vesdana, and I would love to welcome you in front of the entire Joberty team. For those who maybe don't know us, we are a developers community with more than 70,000 users, and our mission is to help in making the perfect match between IT professionals and IT companies. We are currently present in 6 markets: Serbia, Croatia, Romania, North Macedonia, and Slovenia. And we strongly believe that sharing is caring, and that is why we have started this series of free webinars with industry experts. This is our 11th webinar, and this time topic is clean code development. We're going to have some examples in C#, and we are very happy to welcome Milan, a leader, software architect, and high-performance coach. Milan, welcome, and thank you so much for being here.
Thank you very much for this introduction.
Yeah, and one more thing before I go, we're going to have a Q&A section in the end of the webinar, so feel free to ask any question that you may have for Milan. And I don't want to be wasting our precious time any longer, so Milan, the floor is yours.
Okay, thank you. Let me start to share my screen. Let's hope I select the right one in the start.
Yeah, it's the right one.
Okay, do you see the presentation?
Yeah.
Okay. So today we will talk about clean code. It's a bit, let's say, wide known topic. I would say we all probably learned something about this in companies or outside in the book. And let's say this will be some, let's say, presentation which is kind of by the book, but also kind of by my own experience. So I will show some examples and some, let's say, experience from my own projects and my own, let's say, and my colleagues, what we found, what is good about clean code, and maybe what is not so good about clean code. So in short, as it said, let's say I have more than 20 years of experience working with different kinds of teams and different companies. I'm currently Microsoft MVP for developer technologies and .NET, and I, let's say, write on different platforms, and I have, let's say, I somehow have currently a lot of followers. So the thing is that I like to share knowledge. I like to, let's say, to learn a lot, and I also like to share knowledge, and it seems that people like that. So I think it's a win-win situation for everyone. So let's talk about clean code. First, mention the book. The book was released in 2008 by Robert C. Martin, who is called Uncle Bob, by Prentice Hall. And let's say it was not the first book on this topic. Before this book, there were some other books like Pragmatic Programmer or Code Complete during 1990s. But this was the first book which emphasized, let's say, the code level details. It was targeting more object-oriented programming languages. In the book, it was Java was used, and it was a bit more dogmatic. And so it was like on and off things that you should do and not do. And in the end, maybe some of this stuff was maybe problematic to the whole this approach, and we'll talk about this at the end of the presentation. So let's talk about the code. Why is good code important? When you build application and show it to your user, for example, maybe mobile application, web application, any other kind of application, does your, let's say, user care what is behind? Is the code good or not? Does he care? Probably not. So You just want to see something is built, and you just need to deliver, and that he can see what he wants to see or what he has paid. But there is one thing actually which is happening while you're developing your software, and this thing is called technical debt. And let's say technical debt looks like this in one project. While you're, let's say, developing your software, time available for future development is decreasing, while the time struggling with the complexity and depth is increasing. So in some, let's say, intervals, let's call it maybe sprints or whatever, you will be, let's say, able to deliver less and less software if you don't care about this. And one of the major impacts to technical debt is, let's say, bad code. And okay, this is like bad code, but what is good code? There are different opinions about this. If you ask a lot of people, you will get much more answers on this. But let's to try to have some common ground on this. Martin Fowler wrote this on Kent Beck's design rules, which he wrote in his book Extreme Programming. He said that this is the code that passes the test, that reveals intention, there is no duplication, and you used the fewest elements to do what you need to do. But also, if you take a look at the design principles from big tech companies like Google, Microsoft, Facebook, you can see that this code has clarity. So the code purpose is clear to the reader. It has simplicity. The code accomplishes its goal in the simplest way possible. It has concision. So the code has a high signal to noise ratio. It has maintainability. The code is written such it can be easily maintained. And then consistency. So the code is consistent with the broader code base. So you don't change things here and there with the, let's say, the rest of the code base. And there is this diagram, maybe you saw it, maybe not, which says that during the, let's say, years of programming, your experience and code complexity, you start with super simple code, then you bring a lot of complexities into your code, like design patterns, abstraction interfaces, then you are again at the super simple code. And even though this is a joke, it has a lot of, let's say, a lot of strong roots in the, let's say, reality. So what about the bad code? You all probably saw some kind of a bad code. Here are some examples which I want to show you, but probably saw it, and maybe sometimes you even didn't know why is this code bad. But you feel something is not good here. Like you when you need to do something, you need to do this on many places, some change, or there is maybe some other issues which you find, but it was not clear what exactly is bad here. And if you want to try to define what is a bad code, it is a code that is not easy to understand and it is confusing. The things, classes are coupled. It is not easy to change. So when you change this on one place, you need to change on many places, and it doesn't communicate the intent. So naming is maybe not great and has ambiguous naming. But in the end, we can say the only valid measurement of code quality is number of watermarks per minute. So if you are confused a lot by looking at some code and you don't understand it, it's probably high, let's say, probability it's a not great code. And the thing is, why we write bad code? This is a very important question. There are different answers to this. One answer is, okay, I don't know how to write good code, and clean code is here to help. The other possibility is like we need to do this very fast. We have short deadlines. We are in the speed. We need to take shortcuts, and let's say then we start to write not so great code. There is also one thing which is called broken window theory from the University of Stanford, which says that if you take a look at this building with all broken windows and you hit it with another rock, probably nothing will happen because it is anyway, ruined. But if you see the nice building and you hit it with the rock, then probably someone will chase you. So the mess gets bigger over time, and small things make a difference. So we always, let's say the bad code doesn't start like everything is bad. It started with one single bad decision, and then we let it rot during the time. But what we can do? There are different possibilities. Can we immediately write super great code? It's hard. Many times it's hard, even if you do some nice techniques like TDD and etc. Because we usually want, let's say we as developers, we want to have a working solution first. We want to see, is this thing feasible to do what I want to do? And then when we see this, then we can do, let's say, and improve it. There is, let's say, another possibility. Maybe we just write, let's say, some initial variants of code, and then someone else will do this for us. Let's say improve it. This also doesn't look great, because who is that other person who will fix this for us? And the best way we can do is this thing which Uncle Bob called Boy Scout rule. So leave the campground cleaner than you found it. And what this means? This means every day, when you open your file, start to do something, make a little improvement. Rename a better variable name, refactor to give more meaning, or extract some logic, write a test, apply one of the clean code principles. So try always to leave your code in a better shape than you found it. But then we can ask ourselves, how do I know is my code bad or good? Some people say that good code is like a joke, so you don't need to explain this. And in general, it's not easy. You know, even though maybe you use some principles, you use, let's say, everything you know to make it great, it's still maybe it's a mess. And how we know this? We go from the other way around. We try to find smells in this code. So code smells are warning signs in the code, and we try to detect if this code doesn't have any code smells, and it applies all the, let's say, clean code principles, then this code is probably good. So what kind of code is clean code? So it is code that is easy to understand, simple, has clear naming conventions, good logical organization, modular, express programmer's intent, does one thing well, has tests, and more, of course. But this is the essence. And Michael Feathers, the author, one of the most famous book, working with legacy code, wrote this, that it is code that is written by someone who cares. So you will always see this, that this was written by someone who really cares, who want to be this to be better, even maybe if he doesn't know all the principles and all the patterns and everything. One more thing here, which is important, is this thing called clean code paradox. What this means? If you take a look at let's say cleanness level here and the productivity, we of course don't want to be here and have a messy code with a lot of code smells and with the bad design. But also we don't want to be here in this thing is called coder block overstyling, so that we are constantly improving, we are constantly fixing something, because this is also not good. We want to be here somewhere in the middle. And when we talk about let's say clean code principles, those are main clean code principles. Some of you probably already heard about them, like these solid principles: single point of truth, the principle of least surprise, dry kiss Yagni, encapsulation, separation of concern, single level of abstraction, and some more. But these are, let's say, the most important ones. What are some major topics when we talk about clean code? Naming, commenting, formatting code, functions, testing, error handling. Those are, let's say, most important topics. There are also some other topics, but these are the most important. And let's say how we can make some code, let's say, better. This thing that we can, let's say, do is called refactoring. And what is refactoring? So this is changing the code where we change actually internal stuff, internal organization, but the external stay the same. And in the ideal world, we should use 10 to 20% of time for refactoring. And especially if this refactoring is to remove complexity, then it's always worth it. When we talk about refactoring, there are different kinds of, let's say, refactorings and groups of refactorings, such as compose method, extract method, inline method, moving feature between objects, simplifying conditional expressions, and more. Here you have a link, and you can see all of these refactorings which are available to you. So when we talk about code smells, there are different groups of code smells, and today we will mention all of these groups and some examples from each of these groups. If you want to check, let's say, all of these code smells in more detail and with more examples, you can also check this site. There are also some other websites where you can also see this and check this. So let's talk about the first group. First group are called confusers. Why? Because confusers mean that the reader of the source code is confused, or he misunderstood the code and thus make mistakes. The first one in this group are magic strings. So the magic strings means that the meaning of a number value of string is not clear. So this confuses the reader and lead to misunderstanding. And of course, when you have a magic string like this, which is usually some kind of a string, this magic string value is not checked at compile time. And if this thing changes later, you need to go to multiple places and change all of them without any safety. What is the fix for this is to use, let's say, constant, and then use this constant all over the code. So when we talk about clean code, we must talk about names. And naming is one of the hardest, let's say, thing in software engineering. And how good names look like? Names must reveal your intentions. Try to avoid disinformation. So try to write names which are understandable to someone else than you. Try to be, let's say, in the other people's foot. And of course, names should be also in the context. So if you are working in some context, these names should be familiar to people who understand this context. Use business language. So the closest your, let's say, names in the code are to do business, this is better to you, because I saw many times that a business use one wording and we use in the code other ones. And then it's hard to translate, especially for newcomers. They don't understand, is this code actually is related to this business thing or not? And then you need to go and search this through docs and everything. Don't use, of course, too large names, large enough to explain what you want. And always check the name from the caller perspective. And for this, you can also use always code reviews. So does other people, let's say, understand what I named? If they, if this thing is clear to me and to some other, then probably this is good. If not, then maybe I need to change something. For example, if we take a look at one image like this and we give this to 10 developers, you will probably get different names for all of these items. And this shows how let's say, this shows how this is let's say, complex thing to do. And when we talk about naming, what is not preferred is to use like naming, like in this example, like int d, calc, num, date 1, date 2. These are examples of bad names, because what is calc, what is d, what is date 1? We want to have proper names like elapsed time in days, multiply, start date, end date. And when we name things like this, then we know what is this about. The other smell in this category is flag parameter. What this means? This means that we accept some kind of a Boolean parameter to our methods. And this usually means that we are violating single responsibility principle, because we are actually having some switch or if inside, which is, like, let's say, making different behaviors of this method. So our method is trying to do more than one thing. what is remediation? To create the two methods, every method will do just the one thing. Also, our output parameters. So we pass some parameters inside the method just to return the value. Even though C# allows this, and there are, let's say, different ways to do this, it's not considered very good because it's very, very unexpected. So you have a return value here, and then you also have return values here, and let's say the caller is confused where he need to wait for the return in the parameters or in the return values, and where. So it's a bit confusing. What you can do, of course, to return values instead of output parameters for void methods, or maybe to split method in more methods, so that each method returns return one thing. And of course, in C# we can also use tuples if we must return more than one value. The other smell are called negative conditionals. Let's say our brain is very, very badly wired to understand negative stuff. So if you name things like if this is not something and not or not and not, our brain is very, very let's say struggling with that. And it is much better to name it in a positive way, in a positive condition, like if this is something and something or something. So it's much easier to understand this by someone who will read it tomorrow. The next group of code smells are bloaters. Bloaters are code method classes that have increased so much that they are hard to work with. Some examples are long method and large class. So long method is too long to be overlooked at once and need to be named properly. So you need to do a lot of scrolling, and cognitive capacity is exceeded for remembering the hidden parts of method or to understand it whole. So you need to really to try your best to understand what this method is doing, everything what this method needs to do. And it probably means that it is violating singular responsibility principle. And you will also find usually that some generic names of such methods are used. And how you can fix this, of course, create a composed method with a single level of abstraction, and then extract several sub-methods with intention of revealing names according to their responsibilities. Also, it's similar to large class. If the class is not, let's say, expressing a single clear concept, then it's probably a bad thing. Sometimes such classes are called God objects. So they are hard to understand, hard to read. And of course, you also can do extra class, delegate for field, and move responsibility for them. This is one example of method from one real project I found, which had more than 200 lines. This is just one method. So this method do everything. Go to database, read something, write something, calculate something. It's a really a big mess. Then long parameter list. So the parameter list of a method or constructor contains too many items. So it becomes tough to use that method because the developer has to think about meaningful values for all of those parameters. And how we can fix this is to extract all of these parameters to an object, and of course remove all of these, let's say, others. The next one are data clump. Sometimes different parts of code contain identical group of variables. This is called data clump. For example, parameters for connecting to database, or like in this example, we have data about address of a person, like street name, street number, postal code, city. And wherever you need to do this, you will have, let's say, a duplication of this code. What you can do, of course, is to extract this in address class, and then you use just this address class. And when we talk about duplication, this is don't repeat yourself is a very important concept in clean code. And people maybe don't know that we have different kinds of duplication. We have imposed duplication. So we don't have a choice. We must duplicate stuff because of some constraints. Inadvertent, we don't realize maybe that we duplicated something. impatient, we are in the hurry, we just need to copy sometimes we don't have time to do it properly. And in the developer, multiple people duplicate the same things. So you are not aware that some guy already maybe created this same thing. And this, of course, refers to everything, not only code. This refers to tests, documentation, whatever is duplicated, it is here under this umbrella. But, of course, when we are talking about this concept, try not to be dogmatic, but pragmatic. Why? Because when you strive to eliminate repetition, you might create tight coupling between unrelated components. Even in one module, you might extract common functionality too early, and this can result in unnecessary abstractions that are difficult to modify or extend. So sometimes it's fine to, let's say, to duplicate stuff. But of course, you need to be careful with this and to know why you should not do this. You can also use tool support for this. You have in, let's say, Visual Studio this option which is additionally installed, find matching clones in solution, or analyze solution for code clones, and he will get you all these clones. The next one is primitive abstractions. So use of primitives instead of small objects for simple tasks, such as currency, range, special string for phone numbers. So if we use just primitive types, for example, for phone number, it can be represented as a string, but you don't then have a possibility to do validation, conversion, formatting, and other things that could be done. And then you need to create some other methods, other classes that will do these things. So it's much better to wrap primitive state in usable abstractions on the domain level and move logic as a behavior into it. The next one is also called deeply nested control flow. So you probably saw, so those are these a lot of if-else stuff. What we want to do ideally is to move this if-else to a flat list of conditionals, one after another. Of course, this is not the end. We will talk more about this later. But we don't want to have like this kind of messy code with a lot of if-else, because this is also very much hard to understand. The next group are change preventers. So these smells mean that if you need to change something in one place in your code, you have to make many changes in other places too. And program development becomes much more complicated and expensive as a result. One example is this side effect, which means that a method that does more than its name implies. What this means, for example, we have here a shopping cart with list of items, and we have some method called count number of items. And this method is going through this list and let's say counting. However, he called this method on this item, on every item. And this is clearly a side effect because, okay, we count, but we then do something else. And the caller of this method will be confused. Why is this happened? Why this happened? What we can do, of course, is to split this into two methods. One method will count number of items, and the other one will just do this thing, visit items or whatever you need to do. The next one is shotgun surgery. So this happens when you have single responsibility split into multiple classes. And this means that if you need to make one change of some responsibility, you need to do this on multiple places, on many small changes in many different classes. So this clearly indicates that single responsibility has been split among a large number of classes. So try to spread functionality into a single class. If no such class exists, create a new one with refactoring, of course. Then we have object-oriented abusers. All these smells are incomplete or inconcrete application of object-oriented programming principles. For example, temporary field. Temporary fields get only values under certain circumstances. Outside those circumstances, they are empty. For example, we have a class here with two, let's say, properties, and we have two methods. This method, let's say, do some kind of a calculation, which call another method and set these two values. then this other method do something and use this method which is set here. And this is very, very bad because this code is hard to understand and error prone. We don't know when these two properties will have value and will not have value. What is the remediation for this? To transform field to method parameter and let's say to move this, let's say if you need to have temporary field, to move it close to the, let's say, to usage of those fields. Also, another smell is called deep inheritance hierarchy. You all probably saw somewhere that you have a lot of this hierarchy, let's say deep hierarchies, like abstract shape is shape 2D, shape 3D, sphere, and it could be even more, sphere implementation or whatever. It is sometimes called inheritance nightmare. It's a really big, major cognitive overload. Even though we always start with this, like, okay, I want to have a clear design, good design of maybe some real-world objects and etc. This is really hard to understand code, and understanding the child class normally requires reading and understanding the parent class implementation, which violates encapsulation actually, and also violate KISS principle. So in many cases, what we can do is to replace inheritance with composition and collapse the hierarchy where possible. The other one is the refused bequest. If a subclass use only some of the methods and properties inherited from parents, the hierarchy is not good. How you will find this? You will find this probably if you have like a subclass with methods which has in its body not implemented exception. So this is a not good hierarchy of classes. How we can fix this? Of course, one of the possibilities is to use again composition over inheritance, and here also we are also violating a list of substitution principle. The next one is simulated polymorphic behavior. So we try to simulate polymorphic behavior by repeating switch case statements or if-else block, where we violate dry and open clause principle. Like here we have some kind of pass guest, and then we check if this guest is tourist, then we do something. If this guest is some other kind, then we do something else. We do something. What we want to do, try to create proper, let's say, inheritance for the polymorphic behavior and encapsulate the polymorphic creation of the subtype optionally in the factory, and then you just call this method normally. Then the other group of code smells are couplers. All these smells in this group contribute to excessive coupling between classes, or show what happens if coupling is replaced by excessive delegation. The one example of this is inappropriate intimacy, where the object accesses the internal state or methods of another object, which violates encapsulation and creates high coupling. Like here we have some telephone class with two properties. Then we have another class which has this like class as his property, and then in its method we use this property, and then we access the internals of it, which is really not good. What we want to do, of course, we want to create in this first class public methods and then use only public methods from this other class. So the thing which is available actually and for us, and with this we will not violate encapsulation of this first class. The other example is future envy, where a method accesses the data of another object more than its own data. And we say that we consider it future envy if there are at least 3 consecutive calls to another class. Like here we have a line with 2 points, then we have some calculator in the method, and then this calculator is accessing this line properties multiple times. And what we want to do, if in this case we can move this method inside of the line class, and then he can access, of course, all the internals with move method or extract method. Error codes, what we don't want to do is to return error codes from our methods. We want to return business value, because if we return error codes like shown here, for example, if mount is null, return some kind of error, then we mix business logic and error handling. And this is a really bad thing, because then the caller doesn't know how to deal with this. What we should do, of course, is to use exceptions for this. And when we talk about exceptions, so it is important that at lower levels, we throw exceptions instead of error code. Exceptions must provide adequate context. So intent, failure stage, error type, some failed values, etc. Wrap all errors and exceptions raised by external systems into your own exceptions. So create your own exception. So when this exception happens, you know what's going on. Keep the exception stack trace when throwing. You know probably this with this throw and throw something. So don't lose the stack trace. And of course, don't ignore code errors. Don't create this catch block which are empty, and then you just swallow exceptions so you don't know what happened. And of course, try to use multiple catch blocks instead of if conditions. The next group are dispensables. So dispensable is something pointless or unneeded, which we have maybe in our code. And of course, the first in this group are code comments. So this is a bit hot topic, because in clean code, they are abundant, but in reality, it's not like this. So I will try to reflect on both things here. Clean code says that, let's say, comments violates the dry principle, bloat the code, and eventually ends up being inconsistent with the implementation. Maybe implementation change, someone didn't change the comment, and they potentially even violates the single responsibility principle, because if you need to explain something, that you're probably doing, let's say, more than only one thing. And of course, what we want to do is to remove as much as comments as it is possible. And let's say, we don't want to have comments which describe how, let's say, we do something, but why we did something. I also saw some proposal for like different kind of comments. I mean, please don't do this. Like, we have this one comment or that one comment. So this is really bloating things much more than it is intended to be done. And when we talk about valid use of comments, there are some valid things where we can use comments, like public API comments, some legal comments like copyright, etc. Explanation of intent on top of the file or class. This is also fine. And on complex function or complex code where you want to explain why, but not how. And of course, if we talk about, let's say, dogmatic clean code, the story ends here. But let's say the life is not dogmatic so much. So in large code bases, like 500,000 or 1 million lines of code, somewhere or sometimes you need to have code comments that will help, let's say, people to deal with your code base. But again, we are at the same, let's say, problem where we should have comments and where not. And there is one good thing we can do. It's called one-sentence documentation comments from this book, 97 Things Every Java Developer Should Know, from Peter Hilton. He created one algorithm that you can use in such places. So you write the best code you can, write one sentence doc comment for every public class or method. You then refactor the code, delete unnecessary comments, rewrite all of the bad comments you saw, and only add the detail where necessary. So this will leave you with only those code comments which are really needed. And you will then have only code comments where are, let's say, intended to be. Of course, in this group, we have duplicated code. This thing is really violating directly dry. So similar or equal code at several places in your code. And again, we, let's say the same like we said with the dry. It's very error prone and duplicated. Code has to change because all instances must be found and updated. But be careful with dry. Sometimes it is good to have duplication. Also dead code. So if you see, like, you have old version of method and new version of method, or you have 0 references to something, just remove this. We don't want to have dead code into our code bases. You can also use tools to help you with this, you always have, let's say, source control systems like Git, where you can also always go in history and check for something if something was deleted earlier. Another example of these are C# regions. And why are C# regions not good? Because this usually means that you aim at hiding that the class is too large and thus violates single responsibility principle. If there is a problem with the code, don't hide it, state it. This doesn't mean this is a problem, but it usually, let's say, I found that this means that this class is trying to do many things. And when we talk about code organization and formatting, what we want to do? We want to write high-level code first, and then, let's say, other code or other methods below, so that we can read the code like a book from top-down approach. Of course, you need to group code by their functionality, so to be close to each other, or in the class, or even in same namespaces. Declare temporary variables close to their usage, as we said. Try to adapt company or team-wide code conventions, and then use tools to enforce this. It's always better that tools automate and check everything, and not to leave this, let's say, on the reviews to check this. Avoid too long files, up to 1,000 or 2,000 is okay, not so much behind this. Also, don't write too wide code lines, even though we have now big monitors. Make it up to 70 to 120 characters, and follow proper indentation across code files. And of course, consistent capitalization. So you want to have this in your complete code base to be the same. And when we talk about this clean coding, there is this thing called Clean Code Developer Progression Level. You can check it. But this site, which introduced some levels like black, red, orange, yellow, green, blue, and white, which means that you are on the black level if you are just committed to improve. You are on the red level if you apply all of these basic principles like dry, Yagni, solid. But then you have also other levels where you are using actually automating things, continuous integration, deployment, testing, and white, all of the above. Interesting concept. You can check it here on this site and see where you are. When we talk about clean code and tool support, there are a lot of tools that can help you, like code analysis, SonarQube, Ndepend, ReSharper, editor config, and more, of course. So if you want to read or learn more about clean code, of course, along with the book, there are other books that you can read. There is this book also, maybe even better, a code that fits in your head, which is written actually for C#. Of course, Pragmatic Programmer, The Art of Unit Testing with examples in C# by Roy Osherov, Refactoring, Code Complete 2, Art of Readable Code, Working Effectively with Legacy Code, Design Patterns, Clean Architecture, and Growing Object-Oriented Software Guided by Test. And this book, Philosophy of Software Design, which is, let's say, a bit the different book than Clean Code, because it let's say, propagate maybe some different design principles, but I found some of those principles maybe which are a bit better than this one from Clean Code. And you can also read this and check how this fits into your, let's say, code or coding or design, software design. I think it's a good complementary book to the Clean Code, that you, let's say, produce your own style of creating good software design and good code. And let's talk about critics of Clean Code, because there are some people who say that Clean Code is really bad. And there are two groups of people who say that Clean Code is really bad. The first group is, let's say, this guy calls Case Moratori. He's a game developer in C++. You can check this video. It was released recently, I think 2 months ago, where he actually described one series of examples of this shape, let's say, example, which is usually used for Clean Code, that when you use Clean Code, it is really bad for your performance. And he said that Clean Code is primitive optimization in code flexibility. And to some extent, then there is also, let's say, discussion where he and Uncle Bob continue this discussion in one GitHub repo, and you can see, it's a really interesting, very much, I would say, intellectual discussion between these two guys, where they discuss pros and cons of both approaches. And what we can say, it is probably not ideal for massive amount of calculation on dense array of structs, or if you need, if performances are your, let's say, the topmost one important thing, or you are working on some low-level coding, it is probably not ideal to use this polymorphism or similar stuff, because all of these things are affecting, let's say, your software badly. And but if we are talking about a large code bases, big code bases, where a lot of developers are working, then these things are probably better if you're working in enterprise software and similar. The other group of critiques are, let's say, critiquing the approach itself, like this text called "It's probably time to stop recommending clean code" from this guy called Quantum, where he wrote, let's say, a lot of things. You can check this text if you haven't. Where she said that code cannot be read like a book, duplication is not worth thing, that we said also today. Functions should have more than 4 lines. Names of methods in book are wrong. He found some like bad naming in the book, like this name of this method. He also said that TDD is bad and more. As he said during this presentation, not all things from the book are good. There are some things which are good. There are some things maybe which are not so good. But I would say that clean code has its value, as we saw in some of these examples. There are really good stuff from clean code that you can use, but there are also some stuff maybe that you don't need to let's say use, and you can use some other styles or your own style. Just try to use common sense in every situation. So to conclude, the best code is no code at all. So if you can do something without coding, this is the best thing. If you need to code, then classes should be small and interfaces superficial. Try to choose descriptive names. Try not to have side effects on methods. Use polymorphism where types change faster than operations. Use switch when operation change faster than types. Don't use comments except when you need to explain why. You write tests to cover all significant cases. Use exceptions instead of error code, and be consistent with naming. And of course, avoid negative conditions. And don't forget to be a good Boy Scout. Always leave the ground cleaner than you found it. And of course, try not to write bad code anymore from today. Thank you. That would be it from my side on this topic.
Thank you so much, Milan. So now we're going on to Q&A section. I mean, for now, we only have one question. So if you want to ask something more, please free to ask. So one question that we have is, does microservice help to eliminate bad code?
No, not at all.
Okay, so we have another one. Are traditional software development practices such as clean code becoming less relevant with increasing impact of AI technologies?
I wouldn't say so, and I will try to explain why. I wrote also an article recently about this. If you ask, let's say, AI Copilot or Copilot tomorrow to write some code for you, maybe he will write really clean and good code for you. But if you don't know what is good code, you will don't know, is this actually what is generated good or not? Should you make some changes in that code, or maybe you need to ask him something else to improve that code. So I think it's very, very much important to understand all of these concepts, to understand what is good, what is bad, how to improve it. And then, of course, you could and you should use AI tools like Copilot and others to just help you to be faster, especially when you are, let's say, not junior anymore, because juniors need to know this by hand and to understand all of these concepts.
Okay, so I just want to let everyone know that you will get the recording of the entire webinar via your email tomorrow. So next we have what are you? I mean, it's what do you think about cyclomatic complexity?
What do you mean about cyclomatic complexity? Is that the
yeah, that one?
I mean,
pronounce it right.
Yeah. Well, it's directly related to this. I mean, clean code tried to remove if-else blocks, tried to remove, let's say, large methods, tried to remove all of this stuff, which are actually increasing code cyclomatic complexity. So I would say with cyclomatic complexity, we are on the right track when we are applying clean code principles and clean code in general.
Okay, the next one, does link completely replace stored procedures?
Sorry, I didn't heard.
Does link completely replace stored procedures?
Well, it's not a question about clean code. I mean, it's not related at all. I would say no. And why? There are a few reasons for it. And one of the reasons is, let's say, performance. And there are also more reasons, but it's not related to clean code. No.
Okay, how in large-scale legacy systems clean code practices can be done without breaking the integrity?
Yes. Well, the let's say the remediation is like I said during the presentation. Go into, let's say, into small baby step. Try to refactor every method. Let's say method by method, class by class. Every time you touch it, you improve it by a little. And this is the best way, let's say, to go and fix things. And try not to ask for permission to do improvements. Try always to do to spend 10 to 20% time more and do this improvement than to like say, okay, we don't have time for this, just skip it and we will fix it sometimes. And this sometimes will never happen.
Okay, so now how about fail first in the case of avoid negative condition?
How
about fail first in the case of avoid negative condition?
Fail first, yeah. I wouldn't say that it's directly related. Of course, we can fail fast if we, let's say, have a reason for that, but sometimes we don't have a reason for that. Sometimes we have just a complex business condition where we cannot fail at all. We just need to do some kind of conditions to check for something or to let's say branch. So sometimes it is possible, but in a lot of let's say examples it is not.
Now we have one practical question. If you have a function that takes a complex query that takes for 50 lines, where would you put this query? Would you define it in a class based on Moshe's Udemy course? I don't know if I said it right. In C#, every function should have 5 to 10 lines of code only.
Not sure did I understand this. It's a bit larger, let's say.
Yeah.
Can you repeat?
Maybe it's a bit
complex. I cannot find it. I cannot find it in chat here. Where is that question?
It's in a Q&A section.
In the Q&A. Sorry. I was looking at the chat. Where is that? Practical question. Because question. Complex query. Where you should put this query? Would you put defender based on Mosh? Should have fight. Yeah. This is the question from Nicola. Of course, regarding Mosh Udemy course, this is aligned with the clean code. But complex query that makes over 50 lines. I mean, this sounds a bit scary. Why would it be like 50 lines? This probably can be broken into, let's say, smaller pieces. You can always break complex things into smaller, more simple things. So, I mean, I cannot say on concrete example because I haven't seen it, but in general, you can always break it into more simple stuff and then run on this stuff. Of course, these 5 to 10 lines. This is clean code says that like you should not have more than 4 lines of code, but we all know this is not true. Sometimes we should have, and this is the reason why I recommended the other book, Philosophy of Software Design, where that author professor said that you should have simple interfaces but deep implementation. So, and I am also a bit a favor into that approach. You could have more complex implementation but simple interfaces. So this thing could work very nice.
Next, how can you enforce clean code best practice for a team?
Yes. As I mentioned, try to use like different kinds of tools, linters and SonarQube and this code analysis and other tools where you can enforce like on every build locally in your Visual Studio. You can enforce all of these tools and you get warnings and errors if you, let's say, are not working with all of these code styles you select.
What about depth of inheritance? How deep should we go for and what out for?
What is the right question to this? The least, the best. That's mine.
Does auto-generated code from no-code tools is efficient?
Again, it's not related to clean code, so it's hard to answer this in general. I mean, there are different kinds of no-code tools which generate different kinds of code. So it's a really hard to let's say answer this. But usually, yeah, you will probably write better code than some of no-code tools.
Would you recommend doing modular or monolithic before delving into microservices on a project?
Yes, because I'm not a big fan of microservices, not because they are bad, because we as engineers like to let's say use all of the cutting edge and new stuff, and then whatever is trendy, we will try to squeeze this trendy thing in everything. So we are working on simple problem. We will use the most complex thing. We will immediately hit it with microservices, Kubernetes, whatever we need. And I'm in the other. I'm in this boring technology club because try to use the simple possible solution. And this is where the clean code is also good, and where I like the clean code. Try to use the most simple variant for you. When you are starting to build application, it should probably be some kind of MVP or whatever. Use monolithic application. Try to, of course, create to be modular so you can split it tomorrow if you need it. But you probably need to scale it immediately. When there is let's say that case to scale it, you will scale it later. But don't do it immediately because microservices are having also a lot of burden with them. You need to track a lot of things, logging, let's say this communication between them, and even sometimes you will create this let's say distributed monoliths which are very bad.
Depth of inheritance of classes, is it important and related to clean code?
Yes, I explained this during the presentation. Yes, it is.
Okay. One more question from Nicola. Based on clean code, Mosh in his Udemy course explained that switch cases are code smells. But in this meeting, we said we should use switch cases. He suggested abstract classes instead.
Well, we did not say that you should use switch cases, but sometimes you can, let's say, depending on the case, you can use switch cases. Sometimes you can use strategy pattern. So it all depends on the, let's say, on your case. What is important is that the code you write is clean and understandable to others. So try not to have a lot of complex, let's say, conditionals, a lot of nested if else, even it is the same also for switch. If you have switch with a lot of inside, we also mentioned this simulated polymorphic behavior. So try to find the best solution in your concrete case.
Okay, I guess I don't know if you agree, Milan. We can answer 3 more questions, and if anyone wants to ask Milan further, they can, reach out to you, right?
Yes.
So, what is your opinion on DDD in the context of clean code, and will you maybe have a presentation about it in the future?
Well, I have something in preparation, but it is not. I wouldn't say it's directly connected to clean code. It is. I see it as a design method, and very good design method, especially for larger, let's say, larger cases, larger applications. And I would say it's a more separate topic, and this can be, of course, discussed on a separate presentation.
Does clean code help major performance improvement?
No, as I said and on these critiques, they will probably make your code, let's say, performance to be maybe equally or a bit worse than without it.
Which tool is most preferable for clean code practice, either Sonar Cube or Reshaper?
Yeah, whatever you want to use, Reshaper is local tool, so you install it as addition to Visual Studio. Sonar Cube is a server, so it can also be wired up locally, but you can also, let's say, connect it to your build server, and then on every build, on every pull request, he can run and say if there are any code smells in your code, which are, let's say, in your pull request, or even merge it later.
Okay, so that will be it for this Q&A section. Milan, thank you so much again for this webinar and for joining us and for accepting our invitation. I believe that everyone enjoyed as much as I did. And I would also love to thank everyone for being with us tonight. For the end, I would like to invite you all to register and check out your local Joberty platforms and explore it. And of course, if you have any additional questions, feel free to ask us or Milan. Also, follow us on social media to stay up to date with all the events and things that we are doing. So yeah, Milan, if you want to add something for the end.
Yes, I just want to say thank you for the invitation, and everyone who let's say joined us today for their time, and that would be it from my side. Thank you, and see you.
Thank you.
Bye-bye.
Thank you, everyone, and good night.
Good night.
See ya. Bye.